Okay, this is number 12. And we are supposed to add like terms. Remember, like terms have the same exact exponents on the same exact variables. Now, right now, you can't really even tell what the like terms are because each fraction needs to be simplified so that it only has one a, one b, and one c in it with its exponents, with their exponents. All right, so my recommendation is to just move everything up into the numerator to start out with. Make sure that you are following the rules for exponents. All right. The rules for exponents tell you that when you multiply like bases, you add the exponents. When you raise a power to another power, like right over here, you multiply the exponents. All right, so let's just go ahead and move everything into the numerator. All right, so for the first fraction, I've got 4a to the negative 3, a squared, b to the fourth. I'm going to move that c to the negative 3 up, so it'll become c to the positive 3. Now I've got an addition sign. All right, the numerator is 2a to the negative 1c. I'm going to move everything up to the numerator so that b to the negative 4 is going to become b to the positive 4. That c to the negative 2 will become c to the positive 2. Next fraction, minus 4a to the negative 2a, and then you've got b squared raised to the negative 2, which means you need to multiply those exponents. 2 times negative 2 is negative 4, so b to the negative 4 goes there, and then bring up that c to the negative 3 and make it c to the positive 3. Minus, last fraction, a to the negative 1 bc. Bring that b to the negative 3 up, and it will become b to the positive 3. Bring that c to the negative 2 up, and it becomes c to the positive 2. All right, so you've got everything in the numerator, but now you still need to simplify so that you only have 1a, 1b, and 1c in each term with the proper exponent on each one. All right, so in the first term, you've got 4a to the negative 3 times a to the 2. All right, so you're multiplying like bases. You add the exponents. Negative 3 plus 2 is negative 1, so a to the negative 1. And you've got b to the 4, c cubed. Nothing else to do on that one. Second term, you have 2a to the negative 1. Then you've got a c to the first power and a c to the second power. You add the exponents when you multiply like bases. So c to the first times c to the second is c to the 1 plus 2, or c to the third power. And then you've got a b to the fourth there. Subtracting 4, you've got a to the negative 2 times a to the first. So you add the exponents on the a's. Negative 2 plus 1 is negative 1, so a to the negative 1. Then you've got b to the negative 4, c cubed. Minus. Last term, you have an a to the negative 1. You have b to the first times b cubed. Add the exponents. 1 plus 3 makes 4, so b to the fourth. You've got c times c squared, so c to the first times c to the second is c to the 1 plus 2, or c to the third. All right, you're going to look at each term and see if there are any terms that have the exact same letters with the exact same exponents. All right, the first one has a to the negative 1, b to the fourth, c cubed. The second one has a to the negative 1, b to the fourth, c cubed. So these are like terms. Keep going. This one has a to the negative 1, b to the negative 4, c cubed. That is not like the others. The last one has a to the negative 1, b to the fourth, c cubed. That has the same exact variables as the other two and the same exact exponents, and that's what it has to have in order to be a like term. So 3 of these are like terms, the other one is not. You can only, when you're doing addition and subtraction, you can only combine like terms. You cannot do anything else to the exponents in this problem. You've already done all your multiplication as you went through each fraction. The only time exponents are affected is when you're dealing with multiplication and division, because that's what exponents are about. They're about multiplication. You're multiplying something by itself over and over. So when you're adding and subtracting, like here and here and here, you cannot do anything to the exponents. All you can do is add like terms. So you've got these three like terms. You've got 4 a to the negative 1 b to the 4th c cubed. You've got plus 2 a to the negative 1 3 c to the 4th b cubed. Yeah, whatever. That same thing. And then you've got minus 1 a to the negative 1 b to the 4th c cubed. So 4 plus 2 is 6, minus 1 is 5. So you have 5 a to the negative 1 b to the 4th c cubed. And then you have that other term, which is not like the others, and it's still sitting there. Now you look at the directions for this problem. It says all exponents are supposed to be positive in your answer, and that's not the case right now. So what you're going to have to do is look at each one of these terms and rearrange it so that it has all positive exponents. So this first term here, you're going to want to write 5, and then for that a to the negative 1 power, you need to move it down to the bottom, down to the denominator, so that it's a to the positive 1. The b to the 4th c cubed is already, those exponents are already positive, so they can stay right there. Then the next one, you've got minus 4 a to the negative 1 b to the negative 4 c cubed. The a to the negative 1, the b to the negative 4 do not have positive exponents, so they need to be moved down into the denominator. So you're going to have the 4 there on top. You've got a to the positive 1 now in the denominator, and b to the negative 4th becomes b to the positive 4 when you put it down in the denominator, and then c cubed is still up there in the numerator. This is the final answer. There's nothing else you can do with it. All right, let's look at number 13. Here you have these two big fractions, 3n to the negative 2p over m to the negative 1, and all of that is being raised to the negative 3 power. And now you are multiplying by m squared p squared over n cubed, and all of that stuff is being raised to the negative 2 power. Remember that when you raise a power to another power, you multiply the exponents. So what you're going to have to do here, since this is all multiplication, you can only do this because it's all multiplication, you're going to have to go through each term, each factor in the parentheses, and you're going to have to raise every one of them to the negative 3 power. All right? Every single factor. So, starting with this first big factor here, with this first fraction, go through every factor. 3, you're going to have to raise that to the negative 3. It was raised to the first power to begin with, so 1 times negative 3 is negative 3. So now we have 3 to the negative 3 power. You don't multiply that negative 3 by 3. 3 is the base, not the exponent. You can only multiply the exponents. So the exponent on 3 is 1. 1 times negative 3 is negative 3. So 3 to the negative 3 power. Move on to n. n is raised to the negative 2 power. n to the negative 2 raised to the negative 3 is n to the negative 2 times negative 3. When you raise a power to another power, you multiply the exponents. Negative 2 times negative 3 is 6. Then you've got p to the first power. You're raising it to the negative 3rd. So 1 times negative 3 is negative 3. P to the negative 3. In the denominator, you've got m to the negative 1 power. You're going to raise that to the negative 3 power. So m to the negative 1 times negative 3 makes positive 3. So that's your first fraction. Now we're going to do the same thing with the next part. You're going to multiply all the exponents by negative 2 because you're raising all of them to the negative 2 power, and when you raise a power to another power, you multiply the exponents. So m to the 2 times negative 2, which is negative 4, p to the 2 times negative 2, which is negative 4, and n on the bottom to the 3 times negative 2, which is negative 6. All right, so on this problem, you're still not done with your multiplying now. You need to go ahead and now multiply your like bases. All right, so here you've got, when you multiply all this out, this is all multiplication, and you're not using the distributive property, you're just multiplying it all out. So, I mean, you could rewrite this 3 to the negative 3, n to the 6th, p to the negative 3, m to the negative 4, p to the negative 4. See, it's all being multiplied. M cubed, n to the negative 6. All right? Now, you're going to add your exponents on your like bases. When you multiply like bases, you add the exponents. All right? So, 3 to the negative 3. You've got n to the 6th power here on top. And you can either subtract the exponents on the n's. You've got an n to the 6th on the top and an n to the negative 6th on the bottom. And when you divide like bases, you subtract the exponents. So you could do that. Or you could move everything up into the numerator and work with it that way. Just to be consistent with what I did on the last problem, I'm just going to move everything up into the numerator so it all is nice and clear. So here's the numerator, m to the negative 4, p to the negative 4. If you move that m cubed up to the numerator, it becomes m to the negative 3. If you move the n to the negative 6 up to the top, it becomes n to the positive 6. And now I'm going to go ahead and just add the exponents on the like bases. All right, so like bases, we've got n to the 6th and we've got n to the 6th. We're multiplying like bases, so we add the exponents. So that's going to be n to the 12th. And then we've got p to the negative 3 and p to the negative 4. Add the exponents on the p's. So you'll have p to the negative 3 plus negative 4 is negative 7. All right, then you're going to look at your m's, and you're going to add your exponents on your m's. So you'll have m to the negative 4 plus negative 3 is also negative 7. And then you've still got that 3 to the negative 3 there over here. All right, now all you need to do, you've completely combined all the things you can combine, and now you're going to write it with all of the exponents positive. So the only thing that's going to stay in the numerator is that n to the 12th power. Then you're going to move the 3 to the negative 3 down to the bottom, and it'll become 3 to the positive 3. You're going to move p to the negative 7 down to the bottom, and it will become p to the 7th. You're going to move m to the negative 7 down into the denominator, and it will become m to the positive 7. And now the only thing left to do is to raise that 3 to the 3rd power. 3 to the 3rd is 3 times 3 times 3, which is 27. And that's p to the 7th, m to the 7th. And that's all you can do. That's it. That's the final answer.